Thank you for joining the Iondrive Investor webinar this morning. Iondrive Limited is an ASX-listed company at the forefront of battery research here in Australia, working closely with the industry-leading research team at the University of Adelaide. The ticker for your watch lists is ION, I-O-N. On the call today is the CEO of Iondrive. Ebbe has joined this year and is part of the vastly experienced commercialization team that the company has put together. With backgrounds in the battery tech sector and also in the startup of battery companies, technology companies, and the commercialization of such entities. So a highly credentialed team. The format of the webinar is Ebbe is going to run through a slide pack for about 15 or 20 minutes, and then there will be an opportunity for Q&A through the chat function that's on Zoom here. So you should see that on your screen. So just type in a question at any stage and we will get to them at the end of the formal presentation. So enough from me, over to you, Ebbe. Very exciting story. Looking forward to hearing what you have to say.
And it is a very exciting story, and thanks for that brilliant introduction. I appreciate the kind words. So I'm Ebbe Dommisse, CEO of Iondrive. I've got three main topics to run through the slideshow. The first one is just giving an indication of the market size and the market opportunity. The second is talking more about the technology that we have and why that's different from incumbent technologies. And then thirdly is the team and the execution. So three main topics, but just quickly a summary of what's to come in the presentation. The main prize is end-of-life batteries. So when these electric vehicles come to the end of life, the batteries cannot be landfilled, they're toxic, and they've got considerable economic value with locked-in critical metals that can be recycled ad infinitum. So we're looking at 11 million tons of black mass by 2040. So black mass is, if you segregate the end-of-life batteries, when you start recycling them, you separate into the anodes or the cathodes and electrolytes and so on. The cathode materials containing the metals are ground up into black mass, and that's where the value resides. So that 11 million tons by 2040 represents over $100 billion per annum in recoverable value. So that is the size of the prize, and that's why we're chasing this as our first priority with our technology. Understanding the market a bit better, 70% of the market is captured by China. That's leading the rest of the world by more than a decade in establishing the supply chains for critical minerals and then the manufacturing of batteries and electric vehicles. And the balance really is of that market really is in Europe and the US. So those are the attractive markets for us, and I'll go a little bit more in detail in how we want to penetrate those markets. But this capital raise that we've done is aimed at funding a pre-feasibility study and with the main objective of de-risking this commercialization pathway. So capital raise of $1.5 million that we actually closed the book on $2 million, which we're very excited about, with the overs, allowing not only the cornerstone investors to continue their major shareholding, but also the opportunity for new and exciting investors that we're very excited about. Okay, so that's just what we'll be covering off in this presentation. Just a bit more on the market side to understand this a bit better. I mentioned that the US and Europe will be the target markets for the Iondrive technology. So all of this started with the geopolitical tensions that have arisen post or during COVID and post-COVID with supply chains of critical minerals, and the US and EU realizing that they're behind in terms of securing sovereign energy and transition capabilities. In other words, being able to manufacture themselves electric vehicles and associated batteries. And then legislation, especially in Europe, where given the economic value of those batteries and that energy transition capabilities, is effectively banning the export of the black mass back to China. So having that ability to, within Europe's borders, processing the black mass to extract those valuable metals. These batteries can't be landfill, so there's a ban on landfill because they're toxic. They've got PFAS materials or everlasting chemicals that toxify the groundwater. And so that economic value is also realized in extracting these metals. The legislation also includes things like battery passports. So what that means is that the automotive OEMs or the car manufacturers are actually responsible for the end-of-life batteries. So if a vehicle is in an accident or just comes to its natural the end of life, the battery remains the responsibility of the OEMs to process or recycle in a responsible manner. And the final legislation that's really interesting is Europe has legislated that these recycled metals need to be included in the manufacture of new batteries from 2030 onwards. So it ramps up from 6% recycled metals to 16%, and then by 2040 and onwards, reaching over 60% of recycled metals. So this is also done to overcome the critical minerals deficit. So if one looks at the extrapolated volumes of electric vehicles and the minerals required to produce batteries for those volume of electric vehicles, there's not enough materials being mined on the planet to meet the demand of those metals. So the ability to recycle these batteries for those metals and to close the gap, that deficit, is really important. So that's pretty much what's going on within Europe, and the USA is very similar in terms of the aspirations of the same sovereign manufacturing capabilities, but they're doing it not through legislation but through incentives. So a bit of a carrot stick difference between Europe and America with Biden's IRA Act, and investors would have seen the news from America where billions of dollars are being invested in these capabilities. And for example, I'll allude to it later on in the presentation, but one of the companies in the US that we started discussions with that are interested in our technology, they just completed a capital raise 2-3 weeks ago for $1.3 billion to set up a recycling facility in the States. So to understand this market a little bit better, Iondrive contracted Row Motion, who's a market research organization with their head office in London. So they specialize in the battery industry globally. And the objective of the study was for us to better understand the supply side. So access to black mass is critical for the business case. So understanding that the supply, who the suppliers are, what materials are available. The second part of that study was what the demand side looks like. So who the customers are, at what points in the value chain should we sell our products. So we could either have the option of extracting the metal as metal salts, or valorize it to battery grade materials, or go a step further to PCAM materials and so on. So just understanding that landscape and the opportunities much better. And then the third thing is also what the competition looks like. So a very comprehensive market research study. And I must say it's the first time that I've had the privilege in let's call it a startup organization, where we've had the ability to do such a comprehensive study to understand the business landscape very thoroughly. Just understanding the technology a little bit better and how we're different is typically batteries are recycled either through a pyrometallurgical process or a hydrometallurgical process. So pyromet is very energy intensive, and it's effectively just burning all the materials away until you're left with the valuable nickel, cobalt, and manganese. Even the lithium is 70–80% destroyed in the process. So there is value not on the destruction, as well as very high energy costs associated with that. Hydrometallurgy is something that's very common in Australia in the mining industry. It's been practiced for decades. So typically one would use very high concentrations of mineral acids or bases, all of them very toxic, and very high energy requirements as well. But most importantly is they leave a very large environmental footprint with effectively these strong acids that are toxic are used once off in dissolving all the materials, including the metals, before the metals are precipitated out. But that leaves a large waste stream that needs to be treated. So very high water consumption as well. So great process for effectively recovering the metals, but does leave a very large environmental footprint. So the process that we've developed through collaboration with the University of Adelaide is a very neat process that uses benign organic solvents in a closed loop process. The solvents selectively extract the metals out of the solid materials and are then recycled back into the process. So much less energy intensive, and most importantly, very little waste, so a much smaller environmental footprint. And that narrative certainly resonates very strongly with the markets that we're targeting, Europe and the US. And I'll allude to that a little bit later on. But just wanting to also mention that not only is the recovery of these metals very high with the organic solvents, but they're also extremely good at separating the metals groups, which is a differentiator for us, but also a competitive advantage in that one can selectively isolate these metals as salts and then process them further to battery-grade materials individually, where typically your standard hydrometallurgical processes results in a mixed bag, if you want, of these metals. And having them isolated gives advantages to the downstream battery manufacturers, where they can add these metals in any ratio they want for their battery chemistries. So just some differentiators there on that technology and why that's exciting for regions like Europe and the US. And this slide over here is just giving a visual on where we're playing in this life cycle. So that the two yellow bubbles are secondary focus areas, with the green, the extraction of the metals from the black mass, our primary focus. So that's what we covering in this pre-feasibility study, and the next stage, the pilot plant. So just giving an indication of how the value increases with these different steps. Typically, black mass sells for about $2,000 a ton. And after the metals have extracted, that increases to $8,000 a ton. And when those metal salts, the lithium, cobalt, nickel, and manganese, are then further valorized to battery-grade materials, that escalates to over $20,000 a ton. So that's where we play in the life cycle and where our focus areas are. So a bit more about this pre-feasibility study, where we are now is, if one looks at this as the commercialization pathway, where the technology started in as an idea and then developed in the laboratory at the university. We've then taken over the pathway by doing large bench scale trials, so over 1,000 times scale up to prove the chemistry and some other important process engineering considerations. And that data from the large scale bench trials feed into the pre-feasibility study, which really is focused on de-risking the venture through technology de-risking, commercial de-risking, execution de-risking, and strategic partnerships. And following that, we'll go through a pilot plant scale process, and then commercial plants after that. So just a bit more on the pre-feasibility study, those de-risking areas. On the technology side, I've mentioned how we've scaled up the process 1,000 times. And what we'll do next is contract a high-level engineering project. So that's the EPC contractor to do that process design of a 10,000 ton per annum black mass plant, so that we can do capex and opex, not an estimation. And we'll also do on the commercial de-risking, we'll also contracting a third party in Germany, which we can announce now as PEM at Aachen University, to do third-party benchmarking on our cost drivers from that economic modeling versus conventional plants, capex and opex cost drivers that they've got in their database. So really to understand the deltas in these cost drivers and the capex and opex costs, and what we need to do to address those deltas if required. Then on the execution side, is we're following a stage gate project, but really it's the know-how and experience of the team that's really important in securing solid execution of this commercialization pathway. And then finally, really importantly, is what we've learned on the journey is companies that have embarked on recycling of battery materials really struggle if they go at it not alone. A much smarter way is forming strategic partnerships in consortiums. And in fact, I'm going to be in Europe next week, both in Germany and the Netherlands, in finalizing discussions with both governments and with the aim of signing the MOUs as participants in consortiums that they're establishing for solving this industrial problem. So that's why how these consortiums are set up, by getting representation from industry in all areas of that value chain, from the battery collection right through to the battery manufacturing and the OEM automotive manufacturers. So there's some exciting news flow on that by next week, we anticipate. Just a little bit more on the large-scale bench trials. We've done it in two areas. One is at the University of Adelaide. So this is just the team here on the right and what the equipment looks like. And that's the over 1,000 times, not in the scale up. So that certainly showed that the chemistry scales. And secondly, our major concern was with these benign organic solvents, that any losses either through evaporation or reaction, or leaving with the solids or reporting with the solid particles, could negatively impact the profitability of the process. And we were pleasantly not surprised where these losses are almost negligible, and absolutely critical for the economics of the process. We've also used a third party for independent trialing, Independent Metallurgical Operations, or IMO, in Perth. They completed the trials last week, and just waiting for the analysis to issue their report. But all indications are that the duplication of that trials was equally not successful as at the university. And that step for us is important to demonstrate to investors that that the chemistry works and scales and is or was verified by an independent third party. And then just a little bit on the next step after the pre-feasibility study, which will be the results of the PFS will be the final investment decision for a pilot plant. So we're planning a 1 kilogram per hour pilot plant, moving away from the large-scale batch trials to a continuous process, which will be representative of an actual commercial plant. And we'll first start with a semi-continuous operation where all the unit operations are optimized individually for all the chemical engineering process parameters like flows and temperatures and pressures and ratios, etc., before bolting everything together in a completely integrated closed loop process. And you really want to do that at this scale to iron out any problems that might be associated with a closed loop process. So, simple things like impurities that accumulate in a recycle stream, that you want to understand to what extent that occurs and how you deal with it. Simple bleed streams, for an example. But that's what's planned. It'll probably take about 6 months for the design and construction of the pilot plant, and then 12 months to really optimize it, and then a further 12 months to use it as a test bed for different reagents, different black mass materials, and so on. We've applied for a federal grant, the CRCP grant, which will fund a capital investment like this on a 50-50 basis. And that application is actually submitted today, and the results should be available from the September onwards. And then also, just worth mentioning as a further softening of the investment requirements is that the entire pilot plant project cost, capex, and the operations cost, they're eligible for a 43.5% R&D tax rebate. Obviously, the components covered by the CRCP grant will not be. So effectively, one looks at around about 75% co-funding by government through the grant or the R&D tax rebate, which really softens the investment requirements. Just quickly on the leadership team. So Michael McNeely is the CEO of Strata Investments and also the chair. Jack Hamilton has PhD Chem Eng, been with Shell Global for 20 years as vice president before joining Woodside as leading the Northwest Shelf project, so Australia's largest capital project. And after that, taking on non-executive director roles. Probably the most prominent one is Calyx, that he took from, as chairman, he took from a $50 million market cap to over $1.5 billion before stepping down and taking on other non-executive director roles like Antiotech, that developed silicon technology that they pivoted into battery anode materials. So Jack's got heaps of experience in large capital projects, as well as taking startup organizations through a commercialization pathway, and then obviously the battery technology experience as well. Myself, also a PhD in Chem Eng, been involved with a number of scale-up or startup and scale-up organizations, most notably the last with Circa Group as COO, where we also took a similar novel process from laboratory scale through a series of pilot plants, a demonstration scale plant, and then a successful IPO in Norway, and designing and building of a large-scale plant in northeastern France. And then we've got Ray, the CFO, and the company's the secretary. And then Jeff Rito is our contractor in Europe, so based in the Netherlands. Jeff has got considerable experience in critical mineral supply chain. In fact, sits on a few European think tanks, European Commission think tank on this energy transition. And Jeff has been instrumental in introducing us to those organizations within the Netherlands and Germany that have invited us to potentially participate in those consortiums that I've mentioned. I think it's also worth mentioning just some additional Iondrive assets. We've got the University of Adelaide Strategic Partnership Agreement, where we've got first right of refusal to all of the battery IP that's developed by their Battery Research Institute, that's led by 2 laureate professors and a staff of almost 170. So one can effectively view them as our IP engine sitting in the background, a very large IP engine sitting behind a small startup organization. We've got 2 other technologies licensed from them, which are very exciting technologies, and both of them have got considerably shorter commercialization pathways. The one is a sodium aqueous battery for battery energy storage systems. Now, sodium is available in abundance on the planet compared with lithium, and therefore much cheaper. That sodium aqueous batteries are also non-flammable. So ideal for battery energy storage systems. So that we're looking at either licensing or selling that technology in the short to medium term. And then the same for a lithium-ion NCM811 battery technology that's non-flammable. So very high performance battery. The fact that it's non-flammable, very attractive. So same commercialization pathway. And then we've got the legacy exploration assets in South Korea. Very interesting one is a joint venture partnership with Cobalt. So Cobalt has become well known in the media with their artificial intelligence technology that they've bolted onto their exploration services, and big investment from Bill Gates and Jeff Bezos in Cobalt and the AI technology. And they hit the news a couple of months ago with a very large copper deposit finding in Zambia. So we're really excited about what that joint venture can bring to the lithium tenements that we've got in South Korea. So just quickly wanted to mention that there's some assets here that for short-term liquidity that will also soften that investment blow. Just quickly on for investors, the capital structure. So we're sitting at a market cap of, I think we're over 5.3 million today after the capital raise, and so that's what that looks like. And then just the final slide, just to wrap up, what this capital raise was all about. We targeted $1.5 million. We closed the book on $2 million, and some salient points there that I've already mentioned in the discussion. So I think, Aidan, that's what I had to say. So over to you, and happy to field any questions if and when they arise.
Thank you, Ebbe. Just a reminder that you can ask questions via the chat function here on Zoom.
Battery 30%.
Yeah, so that was obviously a very exciting run through, Ebbe, just while we're waiting for a question or two, especially from an investor's perspective at that market cap that you mentioned at the end. I think it's definitely what you ran through in that market cap, very inconsistent. Perhaps for investors new to the story, a question I keep getting asked is, there's a lot going on operationally within the business from an investment news flow perspective. What should people be looking out for in the next 6 months?
Yeah, so the key activity for us is completing this pre-feasibility study. So that's got the activities of the high-level engineering work, to do the CapEx and OpEx estimation, the economic modeling, the benchmarking. We're also employing a full-time process engineer that will spend his time on the chemistry, and then also working on the design and construction of the pilot plant. So yeah, so it's completion of the PFS, naming these strategic partnerships, of formalizing them in Europe and Germany, and then the major next step would obviously be the investment decision to proceed with the pilot plant.
Great. And so that's all expected in the next 6 months?
Yeah, we want to complete the PFS by 3 to 4 months. And the announcement for the pilot plant will happen very shortly after that. But yeah, those are the main activities in the next not the 6 months. Also, announcements of things like grants that we're eligible for, not only in Australia but also in Europe. So yeah, plenty going on in the next 6 months.
Right, just conscious of time, Ebbe, and anyone else with follow-up questions, please do send them through to me, but maybe just give you an opportunity. We always talk about the elevator pitch, but maybe an opportunity just to sum up very quickly everything you just went through as a takeaway for investors on the call.
So yeah, I think I can just bring it back to those three main things. It's the market opportunity. It is massive. We've got a very interesting play in accessing that market opportunity with discussions in Europe and the US. Secondly is just underlining the fact that we've got a very interesting technology that's different from incumbents. It resonates with especially the Europeans, but also the large players in the US, in that it solves a number of problems, not only environmentally and energy, but also that ability to not to selectively separate these metal groups and then converting them to battery materials. And then the third thing is the execution, the partnerships that we're forming, the team that we've got that's very experienced in this, the commercialization pathway that is very solid. Yeah, I think those are the three key things that I would like to leave with investors.
That's great. Looking forward to the next 6 months. It sounds like it's going to be incredibly exciting, and I'm sure, given all that news flow, we'll be having a number of these webinars over that period. So look forward to catching up with you and the Ion story in the not too distant future.
Great. Thanks, Aidan.
Thank you all for joining the call, and any follow-up questions, please do send them through.